Hello everyone. So I have created this parking system using the Raspberry Pi 4 and Arduino Nano IoT 33. In order to do that, I have connected the ultrasonic sensor with the Arduino Nano 33 IoT and the LED with the Raspberry Pi 4. Now, how this parking system basically works is like if the ultrasonic sensor is near about the distance of 20 centimeters or less, the LED will blink due to that in the Raspberry Pi. So these two devices are communicating with one another using the Bluetooth. So let's look into the code. Then I'll be talking about the circuits and the connections and and showcasing how basically it works. So first, I need to download a Bluetooth library. For that, I have downloaded this Arduino BLE.h library in the Arduino Nano IoT. Then I have this new ping.h for the distance. Then, in order to connect the ultrasonic sensor, the trigger pin is set to be digital 11 and the echo pin is set to be digital 12. Then I have this maximum distance taken to be as 200, and then I have accessed few services. So when I'm talking about this BLE for the Bluetooth, it has service, it has characteristics, and it has handle. So what I mean by these terms, so let's talk about service. If you are accessing a services to detect the temperature measurement, so keep it with that. You are uh, checking the temperature measurements. And then when we are talking about the characteristics, are we reading those measurements? Are we notifying those measurements? Or are we writing on those measurements? Is defined through the characteristics. And what kind of character are we going to pick is due to the handle. So what I mean by that is here I have said that I read the characteristics and it is said to be 12. So what I mean by 12 is I am actually reading it. It is already defined in that particular library, BLE. And so the Bluetooth library is defined earlier, but what I keep on saying BLC is just because it's the BluePy library. So here also I have defined the characteristics, what kind of services I am accessing. I am accessing the distance service, and what kind of handling is done is 180D. So that could be custom according to what type of handling you wanted to do with it. Then I have this again. Then I have set up then I need a setup and a loop. So the setup says the baud rate to be 9600, and then I have begun the Bluetooth service and it says like Bluetooth has actually started or it's failed. The while loop seems to be working for that. So it is giving it a local name, parking sensor. So that means needs to be displayed on the Raspberry Pi in order to like it could actually connect to this parking sensor. Then I have set the advertise service, so it will advertise the distance to the Raspberry Pi, like how close is the ultrasonic sensor to any objects nearby it. Then I have this distance dot service. It adds the character. It talks about the distance, and then the loop, which talks about like sending the signals and whether the connection is there or what kind of distance it is. It is writing the distance on the Raspberry Pi terminal. So let's look into the Raspberry Pi code. And so I have actually used the BluePy library, and then I need so this BluePy library is controlling the GPIO pins on the ultrasonic sensor. So whatever the signal through the ultrasonic sensor is sent to the nano is giving the signal to the Raspberry Pi in order to like whether the LED need to be on or not. Then I have talked about the LED pin. So it is said to be 17. So this is the BCM pin. As I keep on saying, it is the BCM pin. It's not the physical pin, the BCM pin. And then I have set the warnings to be false because they pretty much sometimes it happens that the other users are using the particular same channels to do the tasks. So I have set that false, so we all could use the same channel. Then I have said the GPI pin is given the output. So the address, the target is, so the MAC address of my Arduino Nano is 08 colon B6 colon all that, and then it is using the BTL dot peripheral in order to get the device from it. And after that, it reads the characteristic, so it is reading it. Due to this, I can tell it's reading, so the 12 designs, like what kind of handling it is doing, it's doing the reading. Then all the things, so it receives the data, and if the length of the data is less than, in this case, if the length of the data is less than 4 bytes, it doesn't print anything. But if it only prints if the length of the data is more than 4 bytes, and if the distance is less than 20, it turns on the LED, and if it is not, it keeps the LED off. And if there seems to be no connection at all with the Arduino Nano and the Raspberry Pi, it works with this loop. So let me show you how I ran this code. So before that, I was practicing, like, it's not showing. So what I mean by that is, I was connecting the Raspberry Pi with the Arduino Nano, and it keeps on saying connected and disconnected. So it happened to me 5 times consecutively, and then in later on connected. So it happens, there is a certain faults between the Bluetooth connections. So it could be the latency delay. I haven't gotten myself much into the depth. So let me show you how the circuit works and how it is kind of like calculating the distance and all. So like to say that I haven't used this Arduino Cloud. My other Arduino ID wasn't working, so I just need to show you how the code works. So the distance seems to be around 50, and so the LED doesn't blink. So let me bring my hand closer to the ultrasonic sensor, and as you can see, LED is glowing right now, and it's off again when the distance becomes around 3, or it is less than 20, the LED glows. And so my hand was near the ultrasonic sensor, so the anode is connected to the 17 pin of GPI, and the cathode is connected to the ground of the Raspberry Pi. And then I have this ultrasonic sensors. The trigger pin is connected to 11 digital pin, so this is the one, and the echo pin is connected to the digital pin 12, and then I have this voltage pin and the ground pin. So this is the circuit, and it's working. So that's how you create a connection between the Nano and the Raspberry Pi. Thanks for watching the video.